So in one sense, what we're talking about with vSpool specifically is radical, pulling this functionality out of those point appliances and doing it in the visibility plane. In another sense, it's not that radical. It's really a step toward the separation of hardware and software that's been brewing for some time. If you've read the AT&T Domain 2.0 work, if you've heard John Donovan speak, he's spoken about Domain 2.0 publicly recently. He really describes this very shift. So while the shift's happening inside of large networks, while clearly we've seen this before in server virtualization, and even though software-defined networking is taking a long time to develop, this change has already occurred in other areas. We've seen software-defined networking emerge in the open source community. There's just a lot of startups there, and it's really found a place as an approach to building out network infrastructure products. In some sense, this decoupling is at the very sort of center, a kind of software-defined networking. Decoupling data from applications in an open protocol and in an open format is an area that's developing quickly, and really an iterative step to move toward taking generic functionality out of specific appliances and providing that generalized functionality to more than one service by decoupling it from each of the appliances. So here, capturing and creating PCAPs, this has been done for some time, but capturing and creating PCAPs at 20 gigabit per second and forwarding them to software systems and storage infrastructure, this is really an important element, and it can only be achieved with vSpool. And another sort of, I guess, every presentation needs a Venn diagram at some point. So as we're looking at network function virtualization, or if we're looking at taking advantage of commodity systems, whether that be in server, in applications, or in storage, tying those things together is important. And tying the network to the place where you're going to store the data at large scale, at high performance, at 20 gigabit per second, for example, you need something to bring together the high performance with the ability to use that commodity system. So here, in addition to just having my Venn diagram, I want to describe this approach to big data as a thing that ties together high performance networks with the use of commodity systems. Adopting this big data model, this big data visibility model that uses vSpool, is really an iterative process. It doesn't require that you pitch all of your existing tool sets. It doesn't require that you rip and replace anything. It's not about jumping off into Venn diagrams and three-letter acronyms. It's about taking a measured approach to incrementally increasing the openness of network data. This translates into greater control and efficiency at every point in the data lifecycle. There are certain network analytic functions, especially in security, that require the very tight association of the underlying hardware and software to inspect and to respond to data in real time. For other network analysis functions, that tight association, for many of them, it's not necessary. It burdens the data center with systems that can only offer that siloed view. That traditional model is what we can move away from incrementally. The immediate opportunities for improvement are in compliance, in forensics, in some business intelligence applications that are specific to networks, such as capacity planning. Once that data is out in the open, other uses that benefit the organization, they do emerge once the data is out in the open. But the first things here are really some of the stuff we're doing today, but doing it at larger scale and in higher performance. The mechanism for gaining visibility into the network, the network packet brokers, they're really the pivot point for adapting data to the new model. The architecture shown on this slide, the VSS monitoring visibility plane, here we're capturing and forwarding data to out-of-band tools as well as to active inline tools. The left side of the diagram is known and widely adopted. network packet brokers, NPBs, capture and forward directly to network tools. Network tools analyze network packets in real time and historically. The right side of the diagram, the right side of the slide here, is where the big data model comes in. The big data visibility architecture allows tools to be virtualized and to run on top of alternative computing environments, Hadoop or content platforms or real-time stream processing engines. By providing the data in an open file format that can be directly digested by storage appliances independent of the processing or the analytics functions, the data is liberated, the data is open. You folks who are running networks, it's your data. You can federate it, you can centrally view it, you can run processes on it. You no longer have to lock it up within point systems. You can leverage multiple analytics applications across the same data store simply because the storage is no longer vertically integrated with the analytics tool. So instrumenting network data openness, that's the first step. And rather than trying to stitch together network adapters and disks in a do-it-yourself system, you could adopt a proven visibility plane and then use that very system to forward network data in PCAP for batch use or storage use. So the very system that does packet brokering that enables network monitoring and security applications today can be used for this file creation application. So VSF completes sort of the three legs of the triad here: delivering data to passive tools, working on that true copy of data, delivering it to active tools such as intrusion prevention systems and next-generation firewalls, acting on live data, and now to storage platforms and big data systems in an open format. Try to get closer to a real network diagram here. I think we'll walk forward here a couple slides and get closer to the technology. The near-term use cases for open network data on non-specialized servers include targeted capture for forensics or troubleshooting, whether that's tool-directed or policy-driven or manual. More advanced applications will be able to sustain continuous capture and process and analyze this data for inclusion in a big data platform. So at step one, we sort of do the thing we do today, but also forward to big data platforms. At step two is the functionality that's been there for some time, forwarding off to network tools as a stream of packets. But step three, the big data architecture allows tools to be virtualized and to run on top of other systems, to run on generic servers, to run on virtual hosts, accessing a data store across multiple applications. So this is really as easy as the move to a big data visibility architecture with VSS monitoring is really as easy as adopting vSpool, adding that to a new or an existing network packet broker deployment, and using VNet Connect to capture traffic that comes from virtual hosts. So we have all the traffic from physical hosts and virtual hosts in the visibility plane. And then by using the VSS management console to configure things end-to-end, VMC, the management console, we get a visibility plane that goes all the way from generation and capture to aggregation to filtering to optimization and ultimately storage of that data. Just to quickly summarize here, the point is to decouple storage from analytics to allow network data to be stored more efficiently, to be used in more places, to really manage that network data at scale and more efficiently, to provide network visibility up to those big data systems so we can go beyond performance management and security to new applications. So if you've heard a bit about the why and the what you can do. You heard just a bit about vSpool. If you're interested in how you might move forward, what the next step might be in getting some more technical information from the team here, in part 2 next week, we'll provide specific details and deployment guidance, as well as technical considerations related to scale, flow statistics, open formats, and then how that's important for more than just the PCAP. And leveraging distributed compute models to increase to manage network performance or increase security.
All right. There are a couple questions in the queue right now. We'll go ahead and start addressing these. If you have more questions, you can still enter them into the queue, and we'll go ahead and answer them for you. The first questions we have is.
Let me see. I'll just take the very first one. Do you think the analytics vendors will cooperate with this proposed model? You know, it's we've seen a mixed response. I'll be very frank there. To get to scale, I think this is an approach that has to happen, and we're not wanting to step on anyone's toes, but sometimes the architecture, you know, the requirements decide the architecture that gets proposed. We think there are those who recognize this and who are kind of more aggressively kind of adopting the move to software running on commodity compute, and there are those who are resistant. We're not trying to hurt anyone here. We want to help networks run at higher performance and more securely. So I think that there are those who will embrace this. There are those who won't, and I think there are some applications within a single tool where it will or it won't make sense to look at a common data store. So we've already had some positive feedback, and yes, I have had some challenging discussions as well. Just reading a question here. You know, one question is a big part of managing big data is making the data more intelligent. I think it's more about adding metadata to it. How can the data be more relevant before it's captured and stored? It's really, really good question. So we can filter the data. We can slice packets and remove extraneous data. Timestamping is a critical piece of information that can be added to every packet. And then once we've got that data in the system, generating metadata around the data, metadata around the packets or the PCAP is really the next step, and that's how we make it more intelligent. That's really the focus of the talk next week. How flow generation, for example, might be created from this very data. So I think it's the focus of the talk next week, and it's let's just save that one for next week. So there's a few more questions. There's a bunch of a few connectivity-related questions. I think maybe with that, time to wrap up.
Yes. So there was one question from the audience that he or she had to log out due to connectivity issues. If you are unable to view any part of this presentation, you can always log back in and watch it on demand. It will be available archived for up to 1 year. And again, a PDF copy of this presentation will be emailed to you, as well as the link to watch on demand about 3 days post the event. For the specific questions that ask, will there be any continued professional education credit issue today? We are not associated with any CPE organization. However, if this is something that you're doing with BrightTalk, then that may be a question with your BrightTalk contact person. Thank you everyone for your time, and thank you Andrew for being here today. That was very informative and enlightening.
I really appreciate folks signing in and listening for a bit. Hope to see some of you back, most of you back next week to dig into less of the why and what and more of the how and specific next steps.
Thank you all. We'll go ahead and end the session. Have a great day.